Hello everyone. So what I wanted to do today is to add a supplement to section 2.1 and talk about some of the definitions which are present whenever we form angles with two parallel lines and a transversal going through it. So definitions are all throughout the section in chapter 2, and they're kind of sprinkled throughout, but I wanted to put them all together. So what I suggest you do is just take a piece of paper and just write these out on a separate piece of paper so you have it as a reference. And you really should memorize these definitions. So what I have here is two parallel lines, L1 and L2, and I have a transversal line going through them. And we end up with 8 angles. We have A, B, C, D, E, F, G, and H. So in the previous video, I mentioned that there are some corresponding angles which are going to be on the same side of the transversal. One of them is going to be interior angle, one of them is going to be exterior. And I also mentioned there are interior and exterior angles. So I'm going to expand more on those in this video. So first of all, let's mention the ones we already know, the corresponding angles. So that's going to be our first definition. So the first definition is corresponding angles. And this is the F rule, so basically kind of forms an F letter, whether it's at the facing the proper way or kind of mirrored image of an F letter. So in this case, the corresponding angles are going to be A and E. So I'm going to write all of them out. A equals to E. And again, this is only true if the lines are parallel. So these two angles are going to be exactly the same. C is going to equal to G. And on the other side, we're going to have B equal to F. And the last one is going to be D equal to H. So in this case, we end up with 4 pairs here. So there should be an equal sign here. So that's what we saw in the previous video. Let's take a look at exterior alternate angles. So this means that they're going to be opposite sides of the transversal line T1. So one is going to be on the left side, the other one is going to be on the right side, but both of them are going to be outside of L1 and outside of L2. So the second definition is exterior alternate angles. And we call this the Z rule because if you look at these angles, you're going to see they kind of form like, the pattern kind of looks like a Z letter. So in this case, exterior means again outside of L1, outside of L2, and opposite of T1. So in this case, you're going to have 2 pairs. You're going to have A and H and B and G. So these are going to be equal to each other if the lines are parallel. So A and H and B equal to G. All right. Now, what if you have exterior angles but on the same side of the transversal? Well, this is actually the name of these angles. So we have exterior angles on the same side of the transversal. And that's the actual name. It's a very long name. Okay, so we're talking about angles such as like A and G, B and H. Now, these angles are not going to be the same. They're not going to be equal, but they are going to be supplementary. So this means that when you add them, they will add to 180 degrees. So I'm going to say here the exterior angles on the same side of the transversal are supplementary, which means, let's just add a definition here, supplementary angles add to 180 degrees, okay? Which means that if you add angles A and G, they will add to 180, and if you add B and H, they also add to 180. And again, this is true if the lines are parallel. So we're going to say that B plus H equals 180 degrees. And also we have A plus G equal to 180 degrees. So again, these are supplementary angles. So if they're exterior angles on the same side of transversal, these are going to be supplementary. So those are the two types of exterior angles. Let's take a look at the interior angles. So that's our fourth definition here. So we can have interior alternate. And again, this means that they're going to be on the inside, but opposite from the left and right side of the T. So for example, interior C and F, these are interior alternate. E and D are also interior alternate angles. Now, these angles are going to be also the same. So again, C is going to equal to F, E is going to equal to D. And we also call this the Z rule, because again, the pattern kind of looks like a Z letter. So all we're going to say here is that C equals to F and E equals to D. Okay, so now we have interior alternate, but we also can have interior angles on the same side of the transversal. So in that case, we're going to have angles such as C and E, D and F. And just like with the exterior angles, when you add these two, they will add to 180 degrees. So these are also going to be supplementary angles. So these are going to be interior angles on the same side of the transversal. Okay, and again, these are supplementary. And like I said before, this means that they will add to 180 degrees. So in this case, we have angles C and E. So C plus E will equal 180 degrees. And the other pair is D plus F equals 180 degrees. All right, so almost done. Definition number 6 is the vertically opposite angles. Okay, now the vertically opposite angles are going to be equal whether you have parallel lines or no. Okay, so you can have non-parallel lines. So L1 doesn't have to be parallel to L2 for this to be true. So I'm going to add a comment here that this is true for parallel and non-parallel lines. Okay, so in cases when you're not sure whether the lines are parallel or not, at least if you have vertically opposite angles, you know that those are going to be equal. So in this case, there's quite a few of them. So vertically opposite means, for example, we have C and B. These are vertically opposite angles. A and D are vertically opposite angles. And as you can see here, the lines don't really matter whether they're parallel or not, because this is only like this cluster of angles here. And then on the bottom on L2, we have E is going to be vertically opposite to H, and G is going to be vertically opposite to F. So the lines L1 and L2 don't have to be parallel for this to be true. So let's list them down here. So again, vertically opposite angles are going to be equal whether their lines are parallel or not. And we have A equal to D, B equal to C, E equal to H, and F equal to G. All right, so these are the main definitions that you need to know. Of course, I also added the supplementary in case you forgot the definition from your previous grades. So actually, we can add that in as well as a 7th definition, supplementary angles. And in this case, again, they add to 180 degrees. So there's quite a few of them. If again, we look at our diagram here, we have A, B are supplementary, B and D are supplementary, D and C are supplementary, and C and A are supplementary. So basically they form a straight angle. So straight angle means 180 degrees. So any two lines, or any two angles rather, they will make a straight line. That means that they are supplementary. So we're going to have 8 different pairs of supplementary angles in this case. So we can list them down here. So we're going to have A and B, or you can write A plus B equals 180. Then we have B and C, C and D and A. So that's for the L1. And then on the bottom, we're going to have E and F, F and H, H and G, and the last one is G and E. So again, all of these pairs will add to 180 degrees when you add them together. So all of these definitions, you need to know them in order to actually do a lot of the problems in this chapter. So if you forgot some of these, because you might know some of these already from your previous courses, especially like supplementary angles, make sure you memorize them because we're going to use them in every section. Okay, so that's all I wanted to do. Again, this will help you with most of the questions in this chapter. So we'll do chapter or section 2.2 tomorrow.